for today's lesson, we are writing linear equations. Our objective is I will be able to use a graph to represent linear equations. Our fill in the blank for today is we use the blank axis for the independent variable and the blank axis for the dependent variable. So we're listening out for 2 words for our lesson today. Looking at class practice 1, it says Cody's width of his box is 4 inches more than its length. If the length is f inches and the width is w inches, write an equation to represent w in terms of f. So first we're going to highlight all of our key details, and the first one we're going to highlight is that Cody's width of his box is 4 inches more than the length. So whatever the length is, whatever the width is, it's 4 inches more than the length. And then we're going to highlight that the length is f inches and the width is w inches. And then it says to write an equation to express w in terms of f. Well, we know that w comes first when we're writing linear equations because it's written first. In terms of indicates an equal sign. And then we have f, because we write that next because it's addition, because it's 4 more. So we add 4. Now we're just going to label our independent and dependent variable. Well, our independent variable is f, because it does not depend on anything else. And the dependent variable is going to be w. So this one's our independent, and this one is our dependent. Now simply all we're going to do is work through this problem now. So we're going to substitute 1 in the length. So the width of his box is 4 inches more than the length. So whatever the length is, the width is 4 inches more than that. So if the length is 1 inch, the width is going to be 4 more than that. So 1 plus 4 would give us 5. So whenever the length is 1 inch, the width would be 5 inches. Do the same thing with 2. Whenever the length is 2 inches, the width would be 4 inches more than that. So we would have to do 2 plus 4, which would give us 6. And then for 4, we would do the same thing, 4 plus 4. So whenever the length is 4 inches, we have to add 4, and it would give us our width, which would be 8. And then we have 5, whenever the length is 5, plus 4, which would give us our width of 9. So we've created our linear equation, identified the independent, dependent variable, and we have created our chart. Now we are going to work with our graph that's right over here. And whenever we're working with graphs, our independent variable will always be on our x-axis, and this one's our x-axis. And then I'm going to highlight it in that green for our independence. So this one was the length. I'm just going to write f, and it's the length. And then on our y-axis would be our dependent variable, which was w, which is our width. So now looking at this, we need to do, I'm going to write 1, 2, 3, 4, and 5, because that's how many independent variables and slots we had, and then 5, 6, 8, and 9. So we're just going to label this one is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now looking at this, all we're going to do is we are going to plot our points now. So whenever there was 1, the length of 1, the dependent variable, the width would be 5. So we're going to go up to 5, and we're just going to plot a point right there. Whenever there was a length of 2, the width was 6. Plot a point right there. We didn't have a 3, but whenever there was a 4, the width would be 8. And lastly, whenever there's a 5, the width would be 9. Maybe I should write this a little bit better. And then if I had actual lines, we would create a straight line all the way down. This would have created a straight line, but since I don't have straight lines, it won't mark it correctly. I can fix this one actually. Right there. That one was right here. That one was right here. This one was right here. All on a straight line. All right, moving on to class practice number 2, it says to write an equation to show the relationship between the variables. So instead of filling in the chart, we're now going to pull out of the chart and create a linear equation. So looking at this, we know that the top one is going to be our independent variable. And the bottom one's going to be our dependent variable. And whenever we write our linear equation, our dependent variable always goes on the out first when writing our equation. So it would be v equals. And then now we need to figure out what the other half of our equation would be. So if we had, for every 2 cups of water, there was a volume of 4. Whenever there was 4 cups of water, there was a volume of 8. Whenever there was 6 cups of water, there was a volume of 12. Whenever there was 8 cups of water, there was a volume of 16. So if I added 2 plus 2, it would give us 4. But if we added 2 plus 4, it wouldn't give us 8. So we know it's not adding. It wouldn't be subtracting. It can't be division because it would be a decimal. So it would be adding. So we have to add, or multiplying. So we need to multiply 2 times 2, which would give us 4. 4 times 2, which would give us 8. 6 times 2, which would give us 12. And 2 times 8, which would give us 16. So our linear equation would be v equals 2 times b. All right, and now we're going to take all of the points that we have found and we're going to plot it on our chart. So I'm going to use a different color. So if we know that the x-axis always represents the independent variable, so that would be b, and the dependent variable, which would be v. And we're going to say this one is 2, 4, 6, 8, and 10. And this one is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Because we only have to go up to 16. So now looking at this, we're just going to plot. So if we know that whenever there were 2 cups of water, the volume was 4, so we're going to go up and make a plot right at 4. Whenever there were 4 cups of water, there was a volume of 8. Whenever there were 6 cups of water, there was a volume of 12. And whenever there were 8 cups of water, there was a volume of 16. Whenever we're plotting, we just got to plot the best we can. And all we're going to do now is create a straight line, because it did give us a straight line. Looking at you, try number 1. It says Janet sang X notes and Michael sang 2 less notes than Janet. If Michael sang Y notes, write an expression to represent Y in terms of X. Go ahead and stop the video, try solving this one on your own, and we'll come back and try solving this together. All right, looking at our equation, if we know that Janet sang X notes, and however many notes Janet sang, Michael sang 2 less notes than her. And if Michael sang Y notes, express Y in terms of X. So we are going to write a linear equation first. And since it says Y in terms of X, we're going to write Y first. In terms of indicates an equal sign, so we're going to write our equal sign. And then we're going to write X next because it's 2 less notes. So X minus 2. Now we're going to plug in our equation into our chart. So whenever Janet sang 5 notes, we're going to plug that in for X. Michael sang 2 less notes, so 5 minus 2 would be 3. Whenever Janet sang 7 notes, Michael sang 2 less notes, which would be 5. Whenever Janet sang 9 notes, Michael sang 2 less notes, which would be 7. And lastly, whenever Janet sang 13 notes, Michael sang 2 less notes, which would be 11. Now looking at our table, we are going to use our chart to plot. And remember, whenever we're working with linear equations and we're plotting on a graph, the x-axis we use for the independent variable, which our independent variable was x. And whenever we're working with the x-axis, a graph, we always represent the y-axis as our dependent variable, which was y. Now we're going to plot on the graph. So looking at the x-axis, we're going to say that this is 5, 6, we're just going to actually write it 5, 7, 9, 13. And then we're going to go up by odds. So we're going to start with 1 first. So 1, 3, 5, 7, 11, 7, 9, 11, 11, 13, and 15. Now we're just going to plot on the graph. So whenever Janet sang 5 notes, Michael sang 3 less notes. So we're going to make a point right there. Whenever Janet sang 7 notes, Michael sang 5 less notes. Whenever Janet sang 9 notes, Michael sang 7 notes. And lastly, whenever Janet sang 13 notes, Michael sang 11 notes. And all we're going to do now is we are going to create a straight line on our graph. And there we go. There's you try number 1. Lastly, looking at you try number 2, it says write an equation to show the relationship between the variables. So if you want to go ahead and stop the video, try solving this one on your own, and we'll come back and we'll see if we have the same answer. So looking at you try number 1, the distance traveled in miles is s, and the time taken was u. So we have to figure out, we know that this is our independent variable, and whenever we're writing on a graph, our x-axis always indicates our independent variable. So our independent variable was s. And whenever we're writing on a graph, our y-axis always is our dependent variable, which is u. Now we got to figure out, how did we get from 12 to 3? How did we get from 12 to 3? How do we get from 16 to 4? How do we get from 20 to 5? And how do we get from 24 to 6? So looking at this, well, we know that the top number is bigger than the bottom number. So it either has to be dividing or multiplying or dividing or subtraction. So looking at this, we're going to try dividing first. Well, what divided by 12 will give us 3? Well, I know 4 divided by 12 will give us 3. Let's look at 16. What divided by 16 can give us 4? Well, 4 times 4 will give us 16. Looking at 20, I know that 20 divided by 4 will give us 24. So it looks pretty consistent that our linear equation would be u equals s divided by 4. Now all we're going to do is plot on our graph. So whenever the distance was 12, so we're going to start at 4, 8, 12, 16. So we're going to do 12, 16, 20, 24, 28. And then we're just going to do 1, 2, 3, 4, 5, 6, 7, and 8. Now we're going to plot on the graph. So whenever the distance was 12, the time taken was 3 minutes. Whenever the distance was 16, the time taken was 4. Whenever the distance was 20, the time taken was 5. Whenever the distance was 24, the time taken was 6. And now all we're going to do is create a straight line on our graph. And there we go. Looking at our fill in the blank, it says we can use the blank axis for the independent variable and the blank axis for the dependent variable. So we're going to use the horizontal axis for the independent variable and the vertical axis for the dependent variable.